Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy.
This will need a revision of our current knowledge of the cosmos. The James Webb Space Telescope has revealed a revelation that totally disproves the Big Bang Theory, the most comprehensive cosmic theory that explains our origins. According to deGrasse Tyson, the Webb telescope discovered black holes from a past universe that gave rise to our own. The James Webb Space Telescope is upending the apple cart, and we suddenly realize that we may need to rewrite all of the textbooks on the universe's beginning. Is it time to update our understanding of the universe? If so, how will the modifications affect things? Come along as we explore James Webb's puzzling discoveries. Could the Big Bang measurements have been insufficient or erroneous? We will discover newly discovered galaxies revealed by James Webb. One of the most important scientific discoveries of the last century was the development of the notion of the hot Big Bang. According to this view, the cosmos was initially denser, hotter, and more homogeneous. The idea was presented as a plausible substitute for the conventional theories of cosmic expansion, and it was amazingly validated in the 1960s with the discovery of the primordial fireball, now called the cosmic microwave background. The Big Bang idea has dominated attempts to explain the universe's genesis for more than 50 years. Astronomers and astrophysicists have long expressed worries about both cosmic inflation and the Big Bang, but the James Webb Telescope has discovered a new issue. Its basis is an inflationary epoch that preceded the Big Bang. By giving the cosmic myth greater complexity, James Webb added to it. It might change our knowledge of the cosmos if it finds early galaxies that are far larger than expected. The discovery of these massive galaxies in the early universe by James Webb raises the possibility that our current conception of the cosmos has to be updated. Current astronomical models contradict this finding. Although it has only been in use for a short time, the James Webb Space Telescope has already yielded previously unseen data about the cosmos in the first few 100 million years following the Big Bang. Everything is aflutter because of the James Webb Space Telescope. We just came to the conclusion that all of the textbooks that describe the universe's beginnings could require revision. The formation of massive galaxies brimming with stars is one astounding discovery. Scientists have used the infrared sensing equipment of the James Webb Space Telescope to detect 6 massive galaxies that were present throughout the early universe. Our knowledge of the beginnings of galaxies might be drastically changed if the magnitude of these objects is verified. These results were later reported in Nature and were based on data from the James Webb Space Telescope. The data shows how the universe was 13.5 billion years ago, or around 3% of its present age. If galaxies are so enigmatic, what exactly are they? Unknown galaxies with age markers comparable to our own Milky Way, which is 13 billion years old, originally emerged 500 to 700 million years after the cataclysmic explosion that gave birth to our universe. One hypothetical monster has a mass 100 billion times that of our Sun, and the stellar masses of these celestial giants are many billions of times greater than our own. There are more stars in our Milky Way than there are suns. In short, these galaxies are far larger than our own Milky Way. I find it puzzling that such huge objects might develop so suddenly, said E.R. Nelson, an astronomer at the University of Colorado Boulder who co-authored the research. We consider this to be a significant discovery and a huge finding. The most exciting thing about the incredible telescope we have sent into space is that it forces us to reconsider how we perceive the universe by revealing unexpected and unexplainable phenomena. During the early cosmos, galaxies with star masses comparable to the Milky Way grew rapidly, unlike what is often believed. Long-held cosmological theories that maintain that the formation of galaxies is a slow process that begins with tiny star and dust clusters are contradicted by this surprise result. The story goes like this: the early universe's sluggish genesis of things is insufficient to account for the massive objects that have just been discovered. The apparent early development of these organisms intrigues Evo Law, the primary researcher. The idea that the universe's large galaxies developed gradually is called into question by this observation. The name universe breakers, which astronomers use informally to characterize these objects, appropriately captures their influence on our comprehension of the expansion of the universe. Although she was not involved in the study, astronomer Emma Chapman of the University of Nottingham in England said that if these findings are confirmed, it might fundamentally alter our understanding of the early cosmos. The discovery of massive galaxies surrounding the Big Bang casts doubt on the idea of a dark cosmic period and raises the possibility that star creation began earlier than previously believed. However, before we begin rewriting the history of cosmos, scientists warn us. Supermassive black holes may conceal some of these beings, according to one theory. The objects that seem like stars in the photos might instead be gas and dust falling because of gravity. The complexity of black hole proliferation and growth in these early phases remains unclear. According to another scientist who is not working on the study, the new evidence does not call into question cosmology, but rather how these things expanded and were created. To confirm their findings, scientists can use spectroscopy to take a picture of the indicated item's spectra, which would reveal their age. The light from these early universe galaxies has been stretched significantly on its way to Earth, as seen by their massive redshift. A greater redshift indicates that the light has been stretched, making the galaxy older and further away. These galaxies have been identified as high redshift candidates, and spectroscopy can reveal their age and if they are really naturally redshifted galaxies from a more recent cosmic era. Even if further observations are required to validate the findings, astronomers believe that the measured mass is a shocking discovery. In any event, even with a 50% reduction in the sample size, the known star mass from this cosmic epoch might be 100 times larger than previously thought. In Nature Astronomy, Michael Bone Culkin, a professor at the University of Texas in Austin, offers a distinctive viewpoint on the topic. According to the most popular cosmological model, lambda CDM, cold dark matter, there was a significant mixing of dark matter with ordinary stuff in the early cosmos. The first galaxies were formed when some of the entangled normal matter became stars when the dark matter halos collapsed. Bone Culkin asserts that the cosmic microwave background provides strong evidence for the early universe's matter dispersion. In order to fit in with the high-mass galaxies that James Webb had found, he set out to determine what percentage of ordinary material should be present. He concluded that starburst stars would have been created using almost every atom in the universe. But this almost perfect efficiency is unachievable, according to Bone Culkin. However, he claims that the existing universe's efficiency is just around 10%. MIT's Mark Fogelberg, who was not engaged in the study, praised the paper's theoretical approach. Vogelberger asserts that a comparatively limited set of assumptions yields the robustness of the estimate. Is lambda CDM no longer taken into account? Despite Boylenkin's calculations, he does not completely reject lambda CDM, stating that it is the most powerful theory and that changing it would only be a last resort. But are there any other possible reasons for this? Unsolved discoveries. Just 500 million years after the Big Bang, Haley Williams, who led a team from the University of Minnesota, revealed the presence of a fascinating early galaxy. Another reason for the galaxy's low appearance is gravitational lensing amplification, which is seen by the James Webb Space Telescope. Compared to galaxies from a somewhat later epoch, tens of times as many stars are generated there. Despite the fact that this galaxy is less in mass than the ones that Bone Culkin studied, Williams makes a rather accurate guess as to whether or not galaxies of larger masses at the same redshift would likewise show comparable intense star creation. Still, Bone Culkin remains wary due to the small size of the object. It is much smaller than the average galaxy, measuring about 105 light-years in diameter. He mulls over the notion that it could actually be a globular cluster. Applying lambda CDM modifications is one possible solution to the cosmic model conflict. Early dark energy suggests changes in dark energy behavior in the immediate post-Big Bang period. The disparities associated with the Hubble constant and other observations may be resolved by this modification. According to these theories, there was more matter in the early cosmos than there is now. According to Bonekin's calculations, early galaxy matter concentrations would quadruple in this scenario, removing the necessity for extremely efficient star formation to provide the same results. However, Compared to the 13.7 billion years deduced from other data, ED models claim that the cosmos is just 13 billion years old. A second hypothesis is that part of the galaxy's light may have come from stars that scientists have mistakenly identified. Boyle and Cullen say that the light is probably caused by accretion disks around supermassive black holes. To yet, only a small sample of these galaxies have been spotted, therefore who thinks this is the most likely explanation? Astronomers warn that the small sample size could not be indicative of the entire cosmos. According to Joel Leisure, a Penn State professor who was not engaged in the study, the perceived tension would vanish if thorough statistical surveys were conducted. However, are these galaxies really so far away? Peter Berui of the University of Arizona, another researcher who was not involved in Bone Cullen's discovery, pointed out that close low-mass galaxies can seem like distant massive ones. Additional measurements are needed to get definitive findings. Most importantly, we still don't have spectroscopic studies of these galaxies, which are essential for figuring out their actual distances and looking for signs of black holes. According to Michael Bone Cullen, new information will make the problem's seriousness clear in a few years, if not sooner. We might look at the scientists' theories on this occurrence to kill time till we get this knowledge. There might be an unknown mechanism at work here. According to some scientists, if we take into account the possibility that enormous black holes existed in the early cosmos, this mystery may be resolved. If this assumption turns out to be correct, astronomers will finally understand the existence of big galaxies in telescope surveys. Explaining the sudden rise in black hole numbers in the early cosmos is the challenge. This is the point at which a very contentious idea put out by a Nobel laureate becomes pertinent. A challenge to credibility, according to the commonly accepted explanation of creation, some 14 billion years ago, everything that exists or ever will exist was contained inside a single, endlessly dense spot. Everything in the observable universe began with this singularity, which exploded at the Big Bang. The Big Bang can be explained at this level of simplicity. However, many scientists still think that 13.7 billion years is not long enough to evolve sophisticated structures like superclusters. A scientist at Oxford University is contesting the conventional Big Bang theory, claiming that the universe was created just 300,000 years ago. He intends to bolster his arguments with cosmic microwave background radiation. According to this scientist, the Big Bang was only one occurrence in a long series of similar explosions known as eons, rather than the beginning of time. These occurrences all mark the start of a new chapter in the universe's history. According to the theory advanced by Roger Penrose, the 2020 Nobel Prize laureate in physics for his studies of black holes and mathematical methods, our universe has had several tremendous bangs and is probably going to experience more in the future. Penrose's contributions to the development of mathematical methods earned him the Nobel Prize. These methods supported and validated Albert Einstein's general theory of relativity. He explained how dense objects collapse under gravity to form singularities, or places with infinite mass, and studied the complexities of black holes. Penrose restated his absurd notion and referred to it as foolish when he collected the prize. As the universe expands, everything will eventually evaporate, leading to a new Big Bang and the birth of an entirely new cosmos. In an interview, Penrose expressed his strong belief that something predated the Big Bang and that humanity still has more to come. The scientist calls his hypothesis conformal cyclic cosmology, but how does he prove it? According to Sir Roger Penrose, who is challenging the Big Bang theory, he has found 6 hot spots in the sky called Hawking points, each of which is around 8 times the diameter of the moon. Named for the late Professor Stephen Hawking, who put out the notion that black holes evaporate after emitting radiation, these points imply the possibility of black holes occurring. However, given the present age of the universe, 13.77 billion years, it is highly unlikely to have been observed. Penrose states simply that our world is not the first nor the last, but rather that it evolved from a highly ordered, tightly packed mass to become the complex reality we see today. Unless anything unusual happened long before the Big Bang, the current inflation-based Big Bang model cannot account for a highly ordered, low-entropy state at the beginning of the universe. Penrose's hypothesis states that our universe has and will revert to a low-entropy state, leaving behind a cold, black, featureless vacuum, as it approaches its final expansion into nothingness. According to Penrose, dead black holes might be viewed as the remains of earlier universes or eons. This might be verified, which would validate Hawking's theory. Penrose presented evidence of hot spherical anomalies in the microwave background in a 2020 research that was published in the Royal Astronomical Society's monthly notices. The Planck 70 GHz satellite provided the data for these locations, which were confirmed by more than 10,000 simulations. Penrose, 2018, suggested that radiation hotspots seen in the cosmic microwave background might be due to black hole evaporation. According to a 2010 cyclic cosmology study by Penrose and V. Gordon, gravitational wave imprints from black hole mergers in an early universe are responsible for the uniform temperature rings in the cosmic microwave background, CMB. Black holes reduce entropy by destroying objects and releasing radiation. The remaining black holes will either combine or vanish when the universe approaches the end of its expansion, restoring some semblance of order. This results in a state reminiscent to the Big Bang by smoothing down the existing ragged structure of spacetime geometry. Penrose's theory states that when the universe stops expanding, it will collapse into a highly organized structure, bringing in a new age that will culminate in the next Big Bang. Contrary to popular belief, Penrose contends that variations in the CMB temperature shouldn't be arbitrary. He and Gordon discovered over 12 concentric rings in the NASA WMAP satellite data, indicating the presence of gravitational waves from thousands of years ago. If confirmed, Penrose's conformal cyclic cosmology would disprove the necessity of a Big Bang antecedent by showing that our universe is only one of many, maybe infinite, eons ago. Though debatable, the idea poses a severe challenge to conventional understanding in cosmology and, if proven true, might have far-reaching effects. The idea that the cosmos may go from being infinitely huge to being extremely small in a single moment, which suggests that particles must lose mass as the universe matures, is difficult for some people to comprehend. Tell us whether you think Penrose's hypothesis is sound or if it's just another Big Bang theory that will eventually be forgotten. Please like and subscribe for more.